Found, but not exploited. This is the gap between bug existing and bug counting. Here's a sentence that everyone loves to write. This results in a remote code execution as root. And here's another sentence the engineer on the other side wrote back. The service doesn't run as root. It runs as www-data. It can't write to the path you've described. Can you attach a working proof of concept for it? That little exchange, that's the whole episode. That's the gap I want to live inside this episode. The distance between found a bug and I can do something with this bug. Because those are not the same thing. They are not even close to the same thing. And a huge amount of bad security research, including some of mine early on, lives in the same space where the researcher quietly pretended they were. You're listening to The Cyber Riddler, where we decipher the offensive and defensive side of the cyber world. I'm Ahmed Mraga. I'm Ahmed. I break into things for a living, and then write reports about how I did it, which means I spend half of my life on the offensive side, and the other half getting fact-checked by people who own the asset. Today, finding versus exploiting, false assumptions that trick findings, and the strange, slightly humbling phenomenon where the person who finds the bug isn't the person who actually understood it. Part 1. Primitive is not a capability. Let me define the gap properly here, because found versus exploited sounds obvious, right? Until you are staring at the write-up at 2 a.m. trying to decide if you have a finding or a fantasy. When you find a bug, what you actually have is a primitive, a small, specific violation of how things are supposed to behave. Like, I can write 1 byte past the end of this buffer. This parameter reaches a SQL string without sanitization, or this deserializer will instantiate a class I name. A primitive is a capability in principle. It's potential energy. Exploiting is the work of tuning the bug into an authorized access, a reliable, useful, repeatable effect that survives contact with the real world. And the real world has its own mitigation here, and guards. The real world has ASLR, so your overflow doesn't know where anything is. It has non-executable stack and heap, so your shellcode just sits there. It has stack canaries and control flow integrity. It has a WAF in front that eats your payload. It has the application running with no shell on the box, no outbound network, a read-only file system, and a user account that can't do anything interesting, even if you are fully owning the process. So, the honest question isn't, is there a bug? There is always a bug. The honest question here is, with the primitive I actually have, under the constraints that actually exist, what can I actually cause to happen, and can I prove it? If you can't answer that, you don't have an exploit. You have a theory, and theories are fine. Half of good research starts as theory, but you have to label it as one. The sin isn't finding a theoretical bug. The sin is writing a theory up as if it were a demonstrated impact. Part 2. It doesn't run as root. Okay, a favorite assumption here. The big one. The one I've been burned by, and the one I see other people's report constantly. Assume the process is running as root. You find command injection in some web application, and then you find an input text, and then you typed ID. You get output. You feel the dopamine. In your head, with no evidence, the impact section writes itself. Full system compromise, root access, game over. Then, someone who actually administrates the box reads your report and says, the daemon dropped privileges at startup. It runs as a dedicated service account, www-data, nobody, app service, whatever, with no sudo entry, no write access outside its own directory, no shell assigned. Your ID output literally said www-data, and you didn't read it. You ran the command that would have told you the truth, and then you choose to ignore that. This always happens, and it's worth understanding why. It's the default failure mode, because the reason is psychological here, not technical. When you are in the offensive side, you are optimizing for impact. You want it to be root. The whole emotional reward structure of finding a bug that has root word on it. So, your brain fills the gap. The solution run as root, not because you checked, but because it makes your finding better. That's motivated reasoning, and it's the single most common way good researchers produce bad findings. The discipline here is boring, and it's this. Establish the security context before you write the impact. What user, what groups, what capabilities? Is it container or not? Is the container privileged or not? Is there a SecComp profile? What can this account actually reach on the network from where it sits? Because RCE as root and code execution as unprivileged service account in a locked down container with no egress are both real findings, but they are not the same finding. And the difference is the difference between critical and medium. When you label the second one as the first, you don't just inflate a number, you burn your credibility and your nice findings. Part 3. Theoretically critical. I want to tell you about a real one here, because it's almost too perfect. It's the curl CVE 2020-19909. And it's a masterclass in the difference between a bug existing and a bug counting. So, curl properly is the most widely deployed piece of software in the Linux system. It's in a billion of installs, maintained famously by Daniel Steinberg. And in 2023, a CVE shows up against it, filled anonymously with the National Vulnerability Database. The description is an integer overflow in the command line parsing of the switch, retry, delay. And NVIDIA rates it as 9.8 critical out of 10. Now, 9.8 is the score you give something that lets an authenticated attacker across the network run code on your box. That's the catastrophe tier. So what's the actual bug? The retry delay option tells curl how many seconds to wait before trying a failed transfer. Curl takes your number, multiply it by 1000 to get milliseconds, and on a crafted value, that multiplication overflows. That's the vulnerability. The impact is, the absolute worst case is the curl waits a wrong amount of time before retrying, or the command line tool actually crash. A denial of service against a program you are running on your own machine by typing your own flag with your own absurd value into it. It had been reported back 2019 by a researcher named Jason Lee on HackerOne and quietly fixed as a regular bug. The same year, there was no security emergency, and then years later, someone reported it back, filled it as a CVE, a new one, and the scoring missionary looked at the word overflow and panic rated it as 9.8. Steinberg's reaction is the thing to learn from. He recognized the description instantly. He had seen the original report, and he went to work to get it rejected, because a false 9.8 against curl propagated to every scanner, every dependency dashboard, every compliance report on the planet within days. A Ubuntu security team looked at it, marked it as a non-security issue. The crash only affected the command line tool, not the library itself. MITRE refused to fully reject it, but flagged it as disputed, and eventually the score came down to a 3.3 low, from 9.8 to a 3.3. Same bug. The bug never changed. The only thing that changed was the people who understood it. The context finally got looked at. That's the lesson, and it cuts both ways. The bug was real. There genuinely was an integer overflow there. The primitive existed, but the report was garbage. Because a report isn't the bug, a report is a claim about what the bug means. And that claim has to survive someone who knows the deployment. Contain the word overflow is not a threat model. Part 4. The assumption. The root thing is the famous assumption, but it's got a whole family. Let me run through the ones I see most, because once you can name them, you stop making them. Unauthenticated when it's authenticated. You found the bug while logged as admin, and you'll forget you were logged in as admin. The reachability of the vulnerable code path requires a session you only have, because you already have the keys. Pre-auth and post-auth are different planets. Always ask who has to be standing where, holding what, for this code even to execute. A race you won once is a reliable race. You hit the window one time out of 1,000 tries and wrote exploitable. Reliability is the exploit. A 1 in 1,000 primitive that you can't make files on demand is a finding that says this is theoretically a race condition, not I can pop this easily. The mitigation isn't there. You wrote a memory corruption exploit in your head and you assumed you can defeat ASLR, but you have no information leak to defeat it. With no leak, no addresses. No addresses means no exploit. It would be exploitable if I had a leak. It's an honest sentence and a completely different finding than it's exploitable. A crash is RCE. This is the big one in memory. You segfaulted the target and called it remote code execution. A crash proves you can influence the process. It does not prove you can control it. Going from I can crash it to I control the instructor pointer and I survive mitigation and I land a payload is 90% of the actual work. And skipping that 90% and writing RCE is just lying with extra steps. The info leak that leaks nothing. Memory disclosure. Okay, you have one. Disclosure of what then? An initialized heap that happens to contain padding bytes. Okay, an SLR bypass is really gold, but a leak of constant zeros is a CVE nobody needs. You will notice that every one of these, the same move, the researcher assumed the most convenient fact in the chain instead of proving it, because the convenient fact made the findings bigger. Finding is optimistic by nature. Exploiting is where the optimism goes to get tested. Part 5. When someone writes it up better than the person who actually found it. Last thing, and it's the one I find genuinely humbling. Sometimes the person who finds a bug, not the person who understands it. And the write-up everyone eventually cites comes from somebody else entirely. Dirty Cow, CVE 2016-5195. A race condition in the Linux kernels, copy on write handling, that lets an unprivileged local user write to memory that's supposed to be read-only. Clean privilege escalation to root. Now, it was found in 2016, and see how he found it. He was investigating a server he managed that had been compromised, and he pulled out the exploit out of a captured HTTP request. It was already being used in the wild. He found it by getting hit with it. Here's the part that gets me. Linus Torvalds had attempted to fix this exact race 11 years earlier. There is a 2007 commit, fix, function name, get user pages, race for write access. And then the fix caused problem on the S390 architecture. And at the time, the race was so hard to trigger that leaving it alone was a reasonable call. It sat there then. Over the years, and related changes to the kernels made the window easier and easier to hit, until what had been a basically theoretical race in 2007 became a rock-solid root exploit in 2016. The bug was known, a version of it was looked at, but that judgment was correct for the time. Found versus exploited isn't just two researchers. It can be the same bug a decade apart. The primitive existed in 2007. The capability only matured in 2016. Same flow. The world around it changed. Here's what I want to leave you with. Whichever side of the report you are on, if you are finding, the bug is the easy part. There is always a bug. Your value isn't the discovery. It's the honesty of the claim you attach to it. Establish the security context before you write the impact. Find out what user it actually runs as. Name every F. Don't promote a crash to RCE, a theory to a demonstration, a 1 in 1,000 race to a reliable primitive. Do a POC or it didn't happen is the thing that separates finding from a vibe. And if you are on the receiving end, reviewing, triaging, owning the asset, the kernel story is your permission slip. A 9.8 is a claim, not a fact. The word overflow is not a threat model. You are allowed to read the ID output, check what user it runs as, and quietly walk a critical finding down to a medium finding, where it belongs. That's not being difficult, that's the job. You've been listening to The Cyber Riddler. If you are reporting bugs or discovering bugs, please share your stories with me. Don't forget to share this episode with anyone you think is interested about this topic. And don't forget to follow us on X at Cyber Riddler or me personally at Al Murabi. Until next time, this is Ahmed Al Murabi signing off.